universe has fast become a favorite alternate worldview among a wide range of people, from staunch academics to sci-fi enthusiasts. It's a thought experiment jointly devised in 2017 and published in 2018 by the University of Rochester astrophysicist Adam Frank and the director of NASA's Goddard Institute for Space Studies, Gavin Schmidt. The Silurian tag is a nod to a particular Earth-dwelling ancient alien race on the BBC sci-fi series Doctor Who. But really, this isn't a novelty idea. Forget sonic screwdrivers and Dalek warlords. The Silurian hypothesis is very much grounded in the real world. At its heart, it seeks to answer a simple question. How do we know there's never been another civilization on Earth? The argument being that since fossilization is uncommon, and since most of the surface of the Earth is less than 2.5 million years old, it should theoretically be extremely difficult to find any direct artifact from a pre-human group if one did exist. Evidence of plastic and nuclear waste might to some degree survive, but even they might have been and gone on a planet that's 4.5 billion years old. Similarly, researchers can study ice cores to analyze trace evidence of ancient epochs, but it's never as though we'll find anything that's incontestable. We've taken a deeper dive at the Silurian hypothesis specifically in a past video, so be sure to check that out next. But no matter how we might go about detecting what may have come before, if we were to imagine that there was something pre-human, then what would that something be like? Clearly, one defining characteristic would be that whatever it was, it's no longer here, which means it either went extinct or it went elsewhere. To a certain extent, an extinction event should be traceable through studying Earth's strata, the thin layers of compacted material that make up the crust of our world. But again, retrospective dating in this way is limited once we reach hundreds of millions and multi-billions of years back in time. Nevertheless, it would perhaps be even more difficult to catch another advanced group if it had relocated, rather than died out. A K2 civilization, type 2 on the Kardashev scale, could be viewed as both not too far away from our own or hugely far away from our own. At K2, the group has harnessed the energy potential of its star system. It's capable of building cosmic megastructures and of colonizing other star systems as it looks to spread across the universe. It has long cracked the puzzle of long-distance space travel and is comfortably set up on a number of planets and moons. For many, this is and should be the direction that humankind itself is heading in, even if we are at the very early stages. We've been to our moon, we're aiming to go to Mars. We've sent orbiters and rovers to the majority of other celestial bodies in the solar system. A K2 is much more advanced then, but it does at least exist along our same trajectory. So if a K2 ever had been on Earth, then what would it have achieved in its time here? Perhaps the key thing in terms of covering its tracks is that a K2 should be fully energy efficient. Whereas the fossil fuels that we use in our lowly state linger for eons, the power that's fueling a K2 should be cleaner, carbon neutral at least, and less disruptive. A K2 should have figured out, for example, a better alternative to plastic, one that isn't almost indestructible, and a material that doesn't leach into the environment in microscopic form. In speculative fiction, writers often use the catch-all term exotic materials to describe anything that's required for some kind of far future, seemingly impossible technology. For a K2, however, those exotic options are mundane, and naturally, they're impossible for us to imagine. If we knew about them, we'd surely be using them by now, and we would exist further up the Kardashev scale than we do. Today, humankind seems to be on the brink of perhaps the biggest energy breakthrough since the Industrial Revolution. For decades, we've had nuclear fission energy, the splitting of the atom that powers, for instance, nuclear bombs. But what we really need is nuclear fusion energy, which involves combining atoms to again create power. It's the same process as what happens inside a star, including our own sun, where hydrogen atoms are fused into helium. If, however, we could take the power of a star and bring it down to Earth, we should then have energy that's limitless and clean. The problem for us at the moment is that while we've long experimented with fusion reactors, none have yet managed to produce net power. They all require more energy to run than what they create. At K2, though, that's another problem that should have been solved. And then, given that fusion energy will reportedly produce far less long-lived nuclear waste, it should again mean that it would be difficult to trace any civilization that was using it. It's another reason why a K2 group in particular could potentially move through space without anyone knowing about it. There are some elements of K2 that perhaps would hang around, however, and none more so than its signature technology, the Dyson sphere. This is a massive frame that gets built around a star in order to siphon away from that star every last unit of energy that it makes. Given the immense local temperatures, it's thought most likely that it would be built and manned by a community of self-replicating machines. At such a close proximity to a star, this just isn't an environment that organic life forms would want to be in. So is there any evidence that our own sun has ever hosted a Dyson sphere? In short, no, there isn't. We can easily see it, so there clearly isn't one around it right now. Our view is in no way obstructed, so we know there aren't any remnants of a past structure still floating around. A speculative science fiction storyline might involve the deliberate destruction of a Dyson sphere as a K2 moves on, perhaps by those same self-replicating robots collapsing and driving it into the sun itself. But ultimately, that really is just a storyline. There has never been any indication that anything like that has actually happened. While then, the Silurian hypothesis arguably shows that a past civilization could be effectively invisible to us in the here and now, perhaps such a civilization actually will have never made it to Kardashev Type 2. Or at least, they will have never properly developed this solar system to match what we would expect of a group at that level. Another hypothetical possibility is that while a past civilization never emerged here, one did once settle here. That way, it would be more like they were paying this system a visit rather than ever calling it home. A group such as that would at once be more difficult to detect once again. Importantly, the Silurian hypothesis is a thought experiment only. It was put forward by Adam Frank and Gavin Schmidt much more as a general inquiry rather than a genuine suggestion for what might have been on Earth before. In this video, we've combined the notion with the prospects for a K2 civilization specifically, and in some ways it works, and in other ways it doesn't. What's your view on whether an ancient Type 2 on Earth is possible? Let us know in the comments. Perhaps in reality, humankind isn't that special after all. Perhaps our planet, our moon, our star, and our solar neighborhood could all have been viewed through the eyes of something else at some point in history. Ultimately, there is no evidence to directly suggest that, but the Silurian hypothesis has, in recent times, asked us all to seriously consider our place in the cosmos.